Hey guys, Andrew here. In the last video we took a look at quite a bit of information where we stepped away from our decimal system, and we moved from a base 10 decimal system, right, 0 through 9, and we moved on to counting any binary system. And we said, hey, we've got these different positional values, 10 raised to the 0, 10 raised to the first, 10 raised to the second, the third, the fourth, so on and so forth. And depending on where a digit falls in those decimal values, it's given a more significant or a less significant value. All right. And if we took all those values and we added them all together, we actually determined the full value of our number. Okay. And then we moved on and we said, all right, well, if we can do that for a base 10 system, why can't we do it for a base 2 system? All right. And we built ourselves a complete number, like a number line here, or a chart, if you will, given our binary values, right? So we could say we have 2 raised to the 0th power, 2 raised to the first, to the second, the third, the fourth, it's a 4. 2 raised to the 5th, to the 6th, and to the 7th. All right. And we drew ourselves a nice little chart here. Okay. All right, and each of these values here, let's kind of just chop this off right at the end. And each of these values here has a different binary equivalent, decimal equivalent to them. So 2 raised to the first is represented by a decimal value of 1. 2 to the first is 2. 2 to the second is 4, 8, 16, 32, 64, and 128. Okay, so we know that, and we could also take some value, all right, and let's say we have a value, a binary value of 1, 1, 1. Let's go with 0, 1, 0, 1, 1. All right. So we had this, we're given this binary value, and based on its positional value, so if we have a 1 in this first most significant bit position with a decimal value of 128, we're going to use this value, right? So 1 times our decimal value of 128. And then we move on and we say we're going to add that column to the next column, and the next column, the next column. Just as we did with a decimal value, we're going to do the same thing with a binary value, all right? So 128, right, we could derive this as 128 plus 64 plus 32. 16 times 0, that's 0, so it'd be either plus 0 or just nothing, right? 8. 4 is a 0, and then plus 2 plus 1, all right? And 128 plus 64 is 192. Plus another 32 should be, let's see, 224. 224 plus 8, let's see if I got this right. 224 plus 8, 232, sorry, 224, 232, 234, 235, okay? All right, so 235. This is right here, this is 235. Okay, but what if I was only given 235, right? When we type into our computers, we give it some IP address. We just give it in decimal, right? And how does the computer actually convert that from that decimal value to a binary value? All right, and it might go through some digital logic process, but we're actually going to go through a slightly simpler routine for determining what our binary equivalent of a given decimal number is. All right, so I'm actually going to erase this out here, and I'll put my 235 up here as a reference. All right, so we'll be back in a second. All right. So now we're back, got this wiped out for us, and we want to take this 235 number and we want to convert it into a binary equivalent. All right, so we're going to go about doing that. So I've got some rules set up over here, but before we get to the rules, we need to get to the basic math that we're going to be using to determine this, and that is called the inequality. And you've probably seen this maybe somewhere around 6th, 8th grade math. And we're going to say that it's, this greater than or equal to, this greater than, this less than thing, right? And we're going to compare two values, right? We might have, just for algebra's sake, right, an x and a y. And we're going to compare two sides or two numbers. And in our case, this x is going to represent this 235, and this y is going to represent each of these bit positions as we go down the list, all right? So we're going to take this 235 and we're going to say, is this 235 greater than or equal to our 128? And then if it is, we're going to follow some set of rules. If it isn't, we're going to continue on with a different set of rules. And we're going to work our way all the way down this line of numbers until we reach the end. Okay, sounds simple enough. So let's take a look at that, all right? What are those rules, all right? So if this value here, this x value, all right, the number we're testing for, our tested value, is greater than, right? If this greater than or equal to, if it is greater than and it happens to be true, we're going to put a 1 in this column. Okay, we're going to put a 1 right here. All right, if it's false, we would put a 0. So determining whether or not on a true condition or a false condition, what will happen? On a true condition, we're going to take this, this y value here, and we're going to subtract, right, y from x, right, to get some new value, all right? And then we're going to continue on now testing this new value against the next y position, the next position. All right. If it's false, if we put a 0 right here, we're just going to continue on with our existing value here, this x, and we're just going to test the next bit position until we get a true value. Okay. So let's actually take a look at this in practice. All right. So again, we're going to say, we're going to do a greater than or equal to inequality, and we're going to be testing our tested value versus our positional value. All right, so let's get started. Okay, our first value, so we're going to start with our 235, all right, and we're going to say 235, is it greater than or equal to 128 in this first most significant. So we're going to start all the way on the left with what is our most significant value. Okay, so our most significant value is 128. All right, so is this true? Is 235 bigger than or greater than or equal to, right, 128? Yes, it is, right? So we put that 1 in that ones column, right? So we put a 1 in there. It's true. All right, and because it's true, we're going to take this 128 and subtract it from this 235. All right, and we're going to get some value, okay, and that value is 107. All right, so we're subtracting it because ultimately we have used up this position's value, right? We've used up 128 because we've given it a 1 value. And because we've used that up in comparison to our 235, we're going to take this value and we're going to take it away from our 235, all right? And we're going to be resulted with a new value, what's left over, okay? So what's left over is our 107, okay? And now we're going to take our 107, all right, we're going to move on to the next position. We're just going to keep on going down the line here. So 107, is it greater than or equal to 64? All right, yes it is. That's true. All right, so we're going to put a 1 in this column. And then once again, we're going to subtract 64 from 107. All right. And we should get a number of 43. All right. And we keep on going, right? 43, is it greater than or equal to the next column, 32? All right, yes it is, right? And then we do this all over again. It gets pretty simple, right? And we finally get down to a number of 11, all right? So 43 minus 32 is 11. All right. Is 11, let's bring this up here, right? So is 11 greater than or equal to, oh, we forgot a 1 there from this guy. Is it greater than or equal to 16? No, it's false, right? 11 is not bigger than or equal to 16, right? So on a false condition, we're going to put a 0 here in this column because our new tested value is not greater than or equal to that positional value. Let's move on. All right, so we literally just move on at this point. And we move on, we keep that 11, and we're going to say, is 11 greater than or equal to 8? Once again, it is, all right? So we're going to put a 1 here, right? And then we're going to take this, subtract it. 8 minus 11 is 3. And then is 3 greater than or equal to 4? No, it's not. We put a 0, it's false. All right, we see where this is going. Is 3 greater than or equal to 2? Yes, it is. Put a value here, subtract 3 from 2, we get 1. And is 1 greater than or equal to itself, which is 1? Yes, it is. We put a 1 here, and then we subtract it, and we get 0. All right? And at the end, we have nothing left. Okay? We go through this, and we just keep on going through this process of taking our tested value and our given value at the beginning, right? Something we're going to test. Is it greater than or equal to? Is it bigger than or equal to our positional value for each of our bit positions, starting on the left, our most significant value, going all the way to the right? All right, and we're just going to keep on going through this process over and over again. And if it's true, you put a 1 there. If it's false, you put a 0. 1, 1, 1, 0, 1, 0, 1, 1. Okay, so this was true, 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 false, true, false, true, true. Okay, all right. And then we're going to look at here, say on a true value, we subtract this value, or this value over here, right? Our tested value minus our positional value. All right. We always want this to be a positive number, no negative numbers here, right? So it's always going to be positive. You could almost say that, it'd be like the absolute value of it. All right. If you put it backwards and you got a negative value, you just subtracted it backwards. All right. Positive values only here. Okay. So we have our positive value. Okay. And we're going to subtract it, and then that is our new tested value, right? Whatever the outcome of that is becomes our new tested value, and then we continue on down the chain. And then once again, if it's false, we just continue on to the next positional value, as we did here, right? Right. And we had 11, it was false, and then we just said 11, and we just moved on, okay? And then as you go through it, so long as all your math is correct and you didn't mess up any of the subtraction along the way, you will find that you always end up with a 0 at the end. Okay? So let me get rid of this here, and let me get rid of this math, and let's backtrack through and just double check our work to make sure it actually works. All right, so we had this 235. We went through the whole process. Is this greater than or equal to the given column? Yes, no, so on and so forth down the list. And now we've arrived at this binary value. So how do we double check our work? We just work backwards, or we actually go forwards, if you will, through testing our values, right? And remember in the last video we looked at it and we said, well, if this bit position has a 1 in it, we're gonna take this given decimal value and add it up in all the positions that a 1 occurs in. So once again, if we have 128 here, we got a 1 here in 128. Next column over, we got a 6 plus 64. Just take the sum of the columns with a 1 in it, plus 32. All right, just as we did before, 16 and 0, so there's a 0 here. So remember when a few videos back when I said, hey, we would take this value and multiply it by this one. So if this was a 7 in the, thousands position, 7 times 1,000, 7,000, right? Same thing here, 128 times 1 gives us the 128. So 16, it's a 0. All right, 16 times 0, or it's just nothing, plus 8. We skip the 4, plus 2, plus 1. and we get our 235. Okay. So now we can see that we can work backwards and forwards through a given address. We can derive a decimal value from a given binary number, and we can also derive a binary number from a given decimal value. Okay. So in the next video, we're actually going to take a look at something called hexadecimal, and then we'll move on to some practice problems in another video, giving you guys a little more coverage on this topic. So I'll see you guys next time.